So hello friend, this is Kaustup Pathare again with a new video. Welcome to our channel Making Maths Easy. So in the previous video we have solved the sums based on the parametric functions. So today this is a new video which is based on the second order derivatives or higher order derivatives. So let's start with the video. So first of all we have, if f of x is a derivable function of x and we have dy by dx is equal to f dash of x. So this term is coined as first order derivative and it is denoted by y dash or y1. So we know that if y is a function of x, means f y is equal to f of x is a function of is a derivable function of x, and we know that its derivative with respect to x is termed as f dash of x, which is also denoted by y dash or which is also denoted by y1, we can see. So we know the first order derivatives. It is a first order derivative, the derivative with the order 1. Okay, so but you know what is the second order derivative? What is the derivative with the order second? Or what is the derivative with the order third? So today I will teach you what is the derivative of second order derivatives, how to simplify second order derivative, how to make the simplification, how to differentiate a second order derivative. So let's start. So if I'm having a function, let's say y equal to x square. So I want to differentiate it with respect to x. So if I told you to find out the derivative, so my dy by dx or derivative of y with respect to x, you will say will be equal to 2x. As we know, the formula is n into x raised to n minus 1, which will be equal to 2x in this case. But I told you, if I told you find the second order derivative with respect to x, which is equal to d square y upon dx square. So what you will do? So we will take the derivative again of this function. So in order to differentiate a second order derivative, we need to differentiate it with the order 1 and then we have to differentiate with the order 2. So my second order derivative can be expressed in the format as d square of y, because y is one and same, so we cannot square the y, but we can square the d square because we are taking the double derivative of it, and upon dx square, means dx the whole square, not dx square, only the not only the dx square, dx the whole square. So dx of square means d ka square also the x ka square, so which will be equal to 2 in this case, because I have taken the derivative of x, as the derivative of x is equal to 1. So the second order derivative of means x square is 2 in this case. So in this way you have to find the derivative or second order derivative. Remember one thing, that a second order derivative is always represented by f double dash of x, or it is also represented using the y2, or we can say y double dash. So we can write here as y double dash, or we can also write as y2 in this case, because second order derivative is always represented using the formula as f double dash of x, which can be also written as f y2, or which can be also written as y double dash. Okay, so in this way you have to represent a second order derivative. This is the first order derivative which I have told you in the previous some tutorials. We were on the first order derivative. We have made the videos on the first order derivatives. So this is the second order derivative. So let's start with solving some sums based on the second order derivative. So we are back with the sum. So for our first sum is x cube plus 5x square minus 3x plus 10. So we have to use the property of finding f double dash of x, or second order derivative. So first of all, let us consider this particular sum equal to y. So y may be equal to this particular sum, and then we have to solve it. So we have to find out dy by dx in this case. So my dy upon d of x will be equal to d upon d of x of this function. So first we have to find the dy by dx, then we have to find the second order derivative of y with respect to x. So first find the dy by dx. So finding dy by dx is quite simple, which is 3x square 3x square plus 10 means 5 into 2, and x the derivative of x square is equal to 2x, so 5 into 2x is equal to 10x, and derivative of x is equal to 1. So with respect to x, so 3x square plus 10x minus 3 will be the derivative or dy by dx of the corresponding function. Now we will find the double order derivative or second order derivative of the corresponding function, so which will be equal to d square of y upon dx square in this case. So we'll find the second order derivative of the function dx square, which will be equal to, first we have to differentiate the x square function where 3 is a constant, so the derivative will be equal to 6x, because x square is equal to 2x, and 3 into 2x gives me 6x plus 10, and my constant minus 3 will be eliminated because derivative of any constant is 0, as derivative of 10x is equal to 10 in this case. So now we have find the derivative, means d square y upon dx square of the corresponding function. So now let's move to the next function. So the next function we have here is x cube into the log x. So we will use here a UV rule in order to differentiate it. So second sum we have, first consider y is equal to the corresponding equation or the corresponding sum, then find the dy by dx in this case. So my dy upon d of x will be equal to d upon d of x of this corresponding function. Now we will use the UV rule in order to differentiate the corresponding function. We know the UV rule, u into derivative of v minus v into derivative of u. So we will use it. So x cube into the derivative of x cube into the d upon d of x of log x in this case, because x cube is my u and log x is my v. So and log x into the derivative of x cube. So we have differentiated we have used the UV rule in order to differentiate the corresponding function. So now let's apply the derivatives. So we will write x cube as it is and differentiate the log x. So x cube multiply by derivative of log x. Derivative of log x is equal to 1 upon x, which is equal to 1 divided by x, and then we have log x over here, and derivative of x cube is equal to 2x. In this case we will write it in the bracket. Sorry, 3x is 3x square, which we will write it in the bracket. So now we have differentiated it. Now we have to find the second order derivative of the corresponding function. So for finding the second order derivative, we will write d square of x upon d square of y upon dx square. So which will be equal to, now we have to differentiate this function. So we will write over here as dy by dx of the corresponding function. So d upon d of x of the corresponding this function, and again we have to use the UV rule over here for differentiation of this part. Okay, so now let's repeat after me. So here it is here it is x cube, and here it is x. So x cube divided by x gives me equal to x square. So we have to differentiate x square in this case. So my derivative of x square is equal to 2x. So I will write it as it is. Okay, so minus log x. So here we have to use the logarithmic rule. So my log x will be my UV rule, log x will be u, and x square will be v. So consider log x is equal to u. So log x into d upon d of x square in this case, log x into dy by dx of x square in this case. So we will represent the log x, we will write it as it is, and then we will remove the 3 outside because 3 is a constant number, and then we will put that x square and we will take the derivative of that x square function. We will also use a bracket over here because when we are using the bracket for simplification, it becomes easy for the simplifying any number or simplifying any logarithmic or derivative function. So we will use a bracket. So we minus of x square, so we have to find the derivative of x square is 2x, and then we have to find the derivative of this particular function. So consider this x square and find the derivative, means d upon d of x of log x in this case, and close the bracket. Now close another bracket, and then always remember to write the brackets because it carries the marks. So 2x minus 3 multiply by derivative of this function. So my derivative of log x derivative of x square will be equal to 2x. So it will be 2x log x minus x square. So we have x square over here. So x square into the derivative of log x, which gives me equal to derivative of log x is 1 by x in this case, I know that. So which will x square is multiplied by 1 by x and 1 upon x in this case. So x square divided by x gives me equal to x, a single x. So the 3 which I have got over here, which I have taken as a common, I will multiply inside the bracket. So the function I will get over here will be 2x minus 3. 3 into 2 gives me 6, so it will be 6x log x minus, sorry, minus, not minus, plus, because here it is a minus sign and here it is a minus sign, so minus minus become equal to plus. So it will be again, I will write over here 3x, because x square divided by x gives me x and 3 multiplied by x gives me 3x. So it is clear. So now 2x plus 3x gives me equal to 5x. So my final answer will be equal to 5x minus 6x, 6x log of x. So this is the final derivative, or the final corresponding second order derivative of the corresponding function, where x cube log x, the second order derivative of the x cube log x, which I have told you. So this we will revise from the first from the starting. So if y is a derivative function of x, then my dy by dx, or the derivative of y with respect to x, will be equal to f dash of x, which is denoted by y dash or y1. Also if we are to find a second order derivative or higher order derivative, we need to differentiate it. Means once we have taken a differentiation of a number, then we have to find a second order derivative. Again we have to differentiate it. If I have to find a third order derivative or fourth order derivative, that much times you have to differentiate the corresponding function. Okay, corresponding dy by dx, means dy by dx is the first order derivative, d square y upon dx square is the second order derivative, d cube y upon dx cube is the third order derivative. So that much times you have to differentiate the corresponding answer which we get by dy by dx. Okay, so let us revise this, that f the double dash of x or y double dash of y double dash or y2 is the corresponding second order derivative, and which is represented by d square y upon dx square. For finding d square y upon dx square, first find dy by dx and then differentiate that dy by dx again, and which will be d square y upon dx square. So in the next video we are going to solve complex second order derivative, which I will be explaining in the next tutorial or next video. So I'm taking a leave. So if you like the video, please share, subscribe and comment on my YouTube channel Making Maths Easy. For more videos related to mathematics, please subscribe my channel. Please like, share and comment on my YouTube videos, and please press the bell icon. So if you get if I upload a new video, so you can get a notification about it. So thank you for watching. Thank you guys.